we learned multiplication properties, and we learned more multiplication properties that included power to a power rule, raising a product to a power. Now we're going to work with division properties. So first we're going to check the skills that we need. We're going to write each fraction in simplest form. Now I would like you to follow along with how I'm going to do this. I don't want you to do some simplification the way you were taught in elementary school. Watch what I do. 5 over 20 is the same thing as 5 over 5 times 2 times 2. I'm prime factoring. I am prime factoring. So the 5's cancel, leaving me a 1 in the numerator, and that is how I get 1 over 4. So let's practice. 60 over 100. That's the same thing as 2 times 3 times 2 times 5. 6 times 10. That's how I did that. 6 times 10, and then I prime factored 6, and I prime factored 10. Now I have 10 times 10. 2 times 5 times 2 times 5. That's 10 times 10. The 5's cancel, the 2's cancel, the 2's cancel, and that's how I get 3 over 5. If I was an elementary teacher, this is exactly how I would teach simplifying fractions, because this is what you need to know, quite honestly, for moving forward in algebra. So 124, I'm going to break that down. That's going to be 62. 2 goes into 62 31 times. So I've got 2 times 2 times 31. I think that's correct. 2 goes into 12, 6. 2 goes into 4 twice. 31 twice is indeed 62. And then in the denominator, 4 is 2 times 2. The 2's cancel, the 2's cancel, and we get 31. Okay, let's move down to 24x over 6xy squared. I'm going to take this and I'm going to resize it. It is way out of the way. There we go. I'm going to take this. I'm going to do the same thing. Resize it. Move it over here. And now I'm going to look at 24x. So 24, this is good practice. 2, 12, 2, 6, 2, 3. 24 is indeed 8 times 3, and then times x, all over 6 is 2 times 3 times x times y times y. The 2's cancel, 3's cancel, x's cancel. So in the numerator, 2 times 2 is 4, and in the denominator, we have y squared. So this is equal to 4 over y squared. 3ac over 12a. 12 is the same thing as 3 times 2 times 2 for 4 times a. The 3's cancel, the a's cancel, and I'm left with c in the numerator over 4 in the denominator. So that's some good practice. You could try and practice with the others. Would not be a bad idea. We're going to move on and talk about the definition of dividing powers with the same base. I have the same base that's a non-zero base, a, and I divide a to the m divided by a to the n. The bases are the same. I'm going to retain that base, and I'm going to take the exponent in the numerator minus the exponent in the denominator. And this is our division property. This is our division property. Let me show you how it works. X to the 5th over x squared. We're going to retain the base of x. 5 minus 2 is 3. So we get x to the 3rd power. Now let me prove to you that it works. X to the 5th over x squared. What happens? Pair of x's cancel, another pair of x's cancel, and we're left with x times itself 3 times, which is indeed x cubed. So let's practice. A to the 6th over a to the 14th. A to the 6th over a to the 14th. I'm going to have 6 a's in the numerator, and in the denominator I'm going to have 14. That is a lot of a's. Now I'm going to cancel all the 6 that are in the numerator. I'm going to cancel all of those out, leaving me a 1. And then how many do we have left over? Well, if I had 14 and 6 of them are gone, 14 minus 6 is 8. So 1 over a to the 8th power. We can also do this using our property. We retain the base of a, and then 6 minus 14 is a to the negative 8, and then we make our exponent positive by bringing it down to the denominator. Let's try another one of those. X to the 4th over x to the 9th. X to the 4th over x to the 9th. Well, all 4 x's in the numerator are going to cancel out, leaving me a 1 in the numerator. And then how many x's will I have left over in the denominator? I will have 5 of them left over. So that's 1 over x to the 5th power. Now is when we have to have a better plan. X to the negative 1, y cubed, x to the 5th, y to the negative 4 in the denominator. Our first step is to make the exponents positive. So that's the first thing I do. It reinforces moving those bases from the numerator to the denominator and vice versa. And it keeps us thinking that our exponents really need to be positive. So this is where I say, does x to the negative 1 stay or go? It's going to go down to the denominator and become x to the positive 1. Does y cubed stay or go? Y cubed stays in the numerator because its exponent is already positive. Now we're at the bottom here. So we're already taken care of x to the negative 1. X to the negative 1 is being taken care of. Y cubed has been taken care of. Now we're moving down to x to the 5th. X to the 5th stays. So it's going to stay in the denominator. Then we have y to the negative 4. Well, that has to move up to the numerator to make the exponent positive. Y to the 4th times y cubed is y to the 7th over x to the 6th. We can also say x to the negative 1 minus 5 times y to the 3 minus negative 4. Well, that would be x to the negative 6 times y to the 7th. X to the negative 6th comes down to the denominator to make its exponent positive, and we indeed get the same answer, y to the 7th over x to the 6th. Okay, here's one for you to try. Y to the 10th over y to the 5th. And hopefully you were saying, well, that was pretty easy. That's 10 minus 5 is 5. That's y to the 5th. And you'd be right. It is indeed y to the 5th. Okay, x squared y over x to the 4th y cubed. If you think about 2x's being in the numerator and 4 being in the denominator, the 2 that are going to cancel out are going to leave 2 in the denominator. So that would be x squared in the denominator. If we think about the y's, that would be 1y in the numerator and 3 in the denominator, one of those would go away and I'd have y squared in the denominator. So x to the second power over x to the fourth is x squared in the denominator, and y over y cubed is y squared in the denominator. And what's left in the numerator? We can always put a 1. We can always put a 1. Okay, here's one for you to try. Make sure you press pause. Okay, on this one, you should have gotten y in the numerator and x to the fourth in the denominator. Put a pretty bubble around it and move on. Now remember to put the line through your z's. X squared, y to the negative 1, z to the fourth in the numerator. X, y to the fourth, z to the negative 3 in the denominator. So I'd have x to the 2 minus 1 times y to the negative 1 minus 4, always the numerator exponent minus the denominator exponent, times z to the 4 minus negative 3. Well, 2 minus 1 is 1. Negative 1 minus 4 is negative 5. And 4 minus a negative 3 is positive 7. We need to write with positive exponents only, so x, z to the 7th stays in the numerator, and y to the 5th is what is in the denominator. Now let's raise a quotient to a power. A quotient to a power means that we'd have x over y times x over y times x over y. And that would be x cubed over y cubed. That's because fractions you multiply straight across. So if I say x over y all raised to the third power, that means each base inside the parentheses is going to get the exponent of 3. So that's the result when raising a quotient to a power. So let's try. 4 over y squared raised to the third power. Well, that would be the same thing as 4 to the third power. That's a base inside the fraction, inside the parentheses. 4 is a base. That gets the third power, and y squared is a base that's also going to get the third power. 4 cubed is from our exponents. 4 cubed is 64. It's a good one to know. Y squared raised to the third power is a power to a power, and that's when you multiply. So we'd have 64 over y to the 6th. Hopefully right now you're feeling really good about all the practice that you got in on those previous lessons, because it's really helping you go through this a lot smoother now, because you recognize a power to a power, you multiply. Very helpful to know, when do I multiply, when do I add, when do I subtract? Okay, here's another example. You can give that one a try if you like. And I got 9, because 3 squared is 9, over x to the 4th. And hopefully you got the same thing. Here's another one. We could just make these tries. So when I give it to you as a try, press pause and make sure that you're trying these on your own. We've got x cubed over y. Oh, I just said the answer. X cubed over y to the 6th. Did we just do that one? Looks very familiar. It looks extremely familiar, does it not? Oh, maybe it was that x cubed. It looks familiar. Here's another one. I'll do this one as an example. X to the 7th over 2 cubed, all to the 2nd power. Now you may not need this. You may say, I don't need you to do this one. So go ahead and give it a try. Press pause. And I'll come back. And I am back. x to the 7th to the 2nd power, 2 cubed to the 2nd power. That would be x to the 14th over 2 to the 6th. And 2 to the 6th is 64. How do I know that? Because 2 to the 5th times 2 to the 1st is 2 to the 6th. And 2 to the 5th is 32. 32 times 2 is 64. That's once again why it's so important for you to know your exponent values. Now let's look at a fraction raised to a negative power. If you have x over y, let's make it a over b. A over b raised to the negative 1 power. I'm going to say negative n power. Let's make it negative n. If I want to make that outside power positive, I flip my fraction, meaning I take the reciprocal and make the outside power positive. Nothing else changes except the outside power. Okay, so 3 to the 5th raised to the negative 2 power is equal to 5 over 3 raised to the 2nd power. And 5 over 3 raised to the 2nd power is 25 over 9. 25 over 9. Okay, time for you to try 3/4 raised to the negative 3 power is the same as 4 over 3 raised to the positive 3 power. 4 cubed is 64 and 3 cubed is 27. So 64 over 27 is our answer. Here I have negative 1 over 2 raised to the negative 5 power. Negative 1 over 2 raised to the negative 5 power. Well, I'm going to make this outside power positive by flipping my fraction. I simply flip the fraction and nothing else changes except for that positive power on the outside. So now I go from a negative power to a positive power. 2 to the 5th power is 32. Negative 1 to the 5th power is negative 1. So my answer is negative 32. Okay, here's another example. 2x over y, all raised to the negative 1 power. I'm going to make that negative 1 power positive by taking the reciprocal of my fraction and then making the outside exponent positive. That's going to be y over 2x for my final answer. Okay, there's one for you to try. And then I'm going to do a couple of others that we're going to try, and then we will be well on our way. Okay, if you gave that a try, hopefully you wrote down c over 7a raised to the 2nd power, and you got c squared over 49a squared for your final answer. Now, what happens if I have a to the negative 4 b squared over c to the 3rd power, all raised to the negative 1 power? Well, that's going to be c cubed in the numerator, a to the negative 4 b squared. We simply take the reciprocal of the fraction. We do not change any signs. We're just taking the reciprocal, and that reciprocal allowed us to put a positive 1 on the outside of parentheses. Now I'm going to have c cubed over a to the negative 4 b squared. I'm going to make my exponents positive by bringing that a to the fourth up to the numerator over b squared. So my final answer in alphabetical order, a to the fourth c cubed over b squared. So the important takeaway here is this a to the negative 4, it does not become positive 4 because that entire numerator just stays the same. It just moves to the denominator to impact this negative exponent. I can prove this by saying, well, a to the negative 4 raised to the negative 1, b squared raised to the negative 1, all over c cubed raised to the negative 1. I'm going to come over here. A to the negative 4 to the negative 1 is a to the fourth. B squared to the negative 1 is b to the negative 2. And c cubed to the negative 1 is c to the negative 3. B to the negative 2 comes down to the denominator, and c to the negative 3 goes to the numerator. And we got our answer. Now, if you like the way I did it just there, you can do it that way. There's lots of different ways that you can do this problem to simplify it. So lots of different ways that you can do this problem to simplify it. Now, what I did with that arrow, I'm going to show you in purple. I just think of it as kind of distributing that exponent to the exponents that are on the inside. And I do negative 4 times negative 1 is 4. 2 to the negative 1 is negative 2. And c to the third power to the negative 1 is negative 3. And there I would simplify it. So a few different ways to think about it and get to the right answer, but whichever one you're most comfortable with that gets you to any of these boxed answers, which are all the same.